Welcome to Breadboarding. This is video 28 in the Breadboard 8088 PC series, PC Compatibility Part 6. So in this video we're going to be testing the keyboard control that we built last time, and the two remaining steps we need after this to get ourselves a bootable MS-DOS PC are adding the DMA controller and the floppy disk controller. In the previous video we managed to get the basic BIOS starting up and writing to the screen. And we also assembled this breadboard with the keyboard controller, output drivers and the PS2 keyboard and PS2 mouse connectors. Now the only trouble was I realised afterwards that I'd made a bit of a mistake on this, in that I'd reused a breadboard that I used on another project, and unfortunately where the breadboard buddy was actually at the other end here, and I orientated it the wrong way around. This basically meant that I had the 60 at the top, number 1 at the bottom, and all of the breadboard PC breadboards I've been trying to put number 1 at the top and number 60 down the bottom, and it also means that the power rails are actually swapped over. So what I've done is I've actually switched around the components. It only took half an hour or so to do it without doing the videoing, and if we just have a look and see what the changes that I made to accommodate this. So this was the board before, so you can see that the red power lines are on the right hand side and the black are on the left, and that down the bottom here the numbers are descending down to 1 here, and we'd have 60 at the top. And you can also see that some of the lines here are going over this connector area, which I'll explain why this was an issue when I come to it. So you can see this wire's coming across here, and these two here are going over this area as well. So this is the relocated board, and you can see now that the red power line's on the left and the black power line's on the right, and this is the same as all the other boards, and we've got 60 down the bottom and number 1 is at the top. What I've also done is, as I moved the board next to the rest of the breadboard PC, I realised that I didn't leave enough space for putting the power connector in here, and so what I have done is built a new power connector to join this board to the existing MDA video card one. It's this connector here I've made on a bit of stripboard Breadboard, and this will actual fact plug in here and will join with the other connector on the other board, and I'll just take out the MDA power connector and replace it with this one. So it just means that we can keep both the boards together and also provide a decent power feed for them. So if we look at the changes, so this was the board before. This is the board afterwards, and you can see now we've got a gap down the bottom here where we've made space for the power connector. We've moved this lead up a little, and these other two leads now just moved over a little, so they've moved over here, so we've got enough space. So hopefully everything else is the same, and now what I'm going to do is to plug this into the main board, and we're going to need to plug in the data bus, the chip select, read, write, A0 signals and things, so that we can connect it up to the rest of the bus. So here's the main PC, we left it last time, and we're going to be fitting our keyboard controller in down here, and you'll see that this is why I need to move some of these power connectors around. So this power connector is going to come out of here. We're going to replace it with our new joiner. And the other reason why I had to change the board round is that the lugs on the side here were going to prevent it from moving up close to the other board. So we just need to make sure this connector goes the right way around. So this is now just going to connect these two boards together and also do the power. Now what I've also realised is the power distribution block up there is, I'm struggling with the camera position to be able to get the whole computer in at the same time. So what I'm going to do is just going to reorganise the power a little bit. I'm going to relocate the power bus over there. I'm just going to need to change some of the cables so that they can all reach, and route them a little bit more cleanly. So you've basically got power cables coming from around here, here, and I just need to tidy it up a little. So when we come back, I'll have cleaned up the power distribution, and then we'll wire up the bus signals here and see if we can plug in a keyboard and get things working. Okay, so I've tidied up the power, so you can see it's routed around. It's a little bit cleaner than it was before, and now the power distribution block is now velcroed at the top right hand corner here, so hopefully there's a bit more space for fitting the camera in. So all I need to do now is to wire in the various control signals and the data lines for the keyboard controller here. So first going to do the A2 line the IO read, IO write, and chip select. And the chip select comes off the IO decoder from the MDA adapter down here, and we'll also be able to get the other signals here from down here as well. And we also need to do reset, which there is a reset coming up over here, so we'll get the reset from over here. So just need to plug the A0 on chip here goes to A2, because we're actually putting this at 6.0 and 6.4 in the IO map. And the IO write goes to write. IO read goes to read. And I need to put in reset. So the reset comes from all the way down there and comes over here. You can just pick that up from there. And then chip select comes from the chip select for keyboard down there and comes in up here. What I'm going to do is to just take the data feed from down here and to wire this in up here. And then we'll then piggyback this one over to here. Make sure we get the purple leads the right way around. So there's just a couple more leads need to connect. So you can see here that test 1 needs to go from pin 39 to the mouse clock output there. So we just need to put a blue line in for that one. So it's going from test 1 here all the way over to the clock output. So that's the blue clock input, that's the blue clock output. There we go. And then there's 2 other connections I need to make. So the keyboard interrupt goes to P24 and the mouse interrupt that goes to P25. And these are going over to the interrupt 4 on the second interrupt controller, and IRQ1 is IR1 on the first interrupt controller. So I need from P24 that's going to IRQ1. There we go. And then the mouse, which is going from P25 over to IRQ4 on the second chip over here. There we go. Now we're just going to hook up a couple of extra lines from the logic analyzer. So we're going to check the clock and the data signals. So the clock is yellow and the data is green. I'm just going to plug in a USB keyboard. This plugs into the keyboard socket there. Okay, we should be all ready to test this out now. So let's just take a look at the BIOS source code, just a few changes that I've done since we did things in the last video. So just make it a little bit bigger. So we're now initializing the keyboard controller we'd previously commented out. I had also initialized the equipment list to be the monochrome display adapter, but I've commented out because that should now be done by the keyboard initialization. And then where we had the jump to the set mode, I've now commented back in the original here. And we've also got this palette include file, which is only called when we've got the breadboard PC, and in fact all of the video initialization logic we need for the breadboard PC is in that palette include file. And then these are just the rest of the test that we were doing earlier. And then the palette include, what this does is has the code necessary to initialize the VGA palette, because we're using this palette digital analog converter to provide all the color output. And you can see here we've got the palette values in here. So basically this just gets called to initialize the palette. Just going to assemble all of that, and then we're going to go to the breadboard PC and power it on. So you can see there Nanocomp. What I'm going to do is to type E6000. So this sets the extra segment to 6000. I'm going to press load. Then we're going to start up the terminal, and we're going to send the breadboard PC srecord file. This will take a few seconds to do, so I'll speed this up. Okay, so that's finished, and we're just going to make sure the logic analyzer is set up. So the logic analyzer is looking at the power on self-test port, but I've also then got the keyboard controller chip select, the keyboard PS2 data clock, and there's also the interrupt line for the keyboard, and the general processor interrupt, and the interrupt acknowledge. Now the reason why I've got these on there is I haven't yet tested that the interrupt controllers are working properly, but this should give an indication if the interrupt controllers are working. So just going to kick this off, and it's triggered on the first power on self-test chip select going low. So the load there has finished. So now we're just going to set the code segment to be 6000, and that should now mean that we'll be ready to actually type go F, 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 and I'll press 0 when we're ready. But what I'm going to do now is to switch over to the VGA capture, and what we should be able to do is to hear some beeps as it powers on, and we should also then be able to see the video initialize, and hopefully we'll be able to see that the monochrome display adapter is actually detected as part of the keyboard controller initialization. It's got the video capture enabled there, and now what I'm going to do is to hit 0 to get it to start up. There's a power on beep, and we can see the memory test, and it's trying to boot the OS, and obviously we've got nothing to boot the OS, so it's saying press a key. So I'm going to press a key again, the enter key. Boot failed, and we might just get another boot failed. Yep. And what that should show us is when we look at the logic analyzer, we should be able to see there's 2 enter keys being pressed there. So that all appears to be working. So you can see on the display adapter we've got NDA or Hercules, and the fact that press key to try to continue, we've got 2 retries, so that seems to be working as well. So if we now have a look at the logic analyzer output, so what we can see here is we've got 25 seconds or so, and what we can see down here, these are the power on self-test codes. So we've got 0102 up to 08. Then we've actually got some keyboard initialization. So this bit here is actually finding the keyboard power on self-test successful. Then as part of the initialization, it disables the keyboard. We get an acknowledgement from the keyboard. Then it enables the keyboard. We get acknowledgement of the enabled. Then we've got the remaining power on self-test codes here, including things like searching for video BIOS and other BIOS extensions. Then we actually get to the 00, which is trying to boot the operating system. And then we can actually see here we've got the make code for the enter key, the break code for the enter key, so that was the first time we pressed enter to retry. Then finally we've got the second pressing the enter key. So we seem to be getting PS2 keys coming in from the keyboard, and we've also got the power on self-test screen coming up on the video display. So it looks like everything's working. So I've completed the PS2 keyboard controller. We'll test the mouse out in later videos when we get on to the next stage of the project, where we're going to try and get an early version of Windows running. But in the next video I'm going to be doing is looking at getting the direct memory access controller, the DMA controller and the floppy disk controller working. And what that should enable us then is to be able to boot an early version of MS-DOS and actually get the Breadboard PC to boot MS-DOS. So if you don't want to miss out on future videos, please hit subscribe, and if you could hit like, it just helps to make the videos available to a wider number of people. Thanks for watching.